Next method is from alcohols. The first one, ROH, concentrated HCl plus anhydrous ZnCl2. This mixture is called Lucas reagent. It gives rise to RCl plus H2O. Different examples we will study later on after doing the roadmap. Second is ROH plus PCl5 to give RCl plus POCl3 plus HCl. Look at this, how it is formed. ROH, PCl3, Cl and Cl. So this will cut it from here, giving rise to RCl, HCl and POCl3. Third is ROH plus PCl3 to give RCl plus. Now see, we are taking 3 molecules of alcohol here and 1 molecule of PCl3 to form 3 molecules of alkyl chloride and 1 molecule of POH whole thrice. This is also called H3PO3. Very important note to remember here that PCl5 is a trigonal bipyramidal molecule. That is, this is trigonal bipyramidal molecule with sp3 dehybridization, while your PCl3 has a pyramidal structure with sp3 hybridization. In PCl5 there are 2 axial PCl bonds, 3 equatorial PCl bonds. So axial PCl bonds are longer and weaker. That is why PCl5 combines with alcohol molecule to form RCl, POCl3 and HCl. While in case of PCl3, it has 3 PCl bonds of equal bond length. That is why it needs 3 molecules of alcohols to form 3 molecules of alkyl chloride, and H3PO3 will be formed as the byproduct of the reaction. Now we are coming to the next one, Darzin's reaction. Darzin's reaction is used to prepare pure alkyl chlorides. Why? Because HCl and SO2 are gaseous products and they are escaped out of the reaction. Alcohol on reaction with SOCl2. This is called thionyl chloride in presence of pyridine. Pyridine is a base. It is used to absorb SO2 and HCl, and those which are not absorbed, they are the gaseous products, so they will be escaped out of the reaction and will give rise to pure alkyl chloride. So it will give RCl plus C, ROH, SO, Cl and Cl. So this is RCl, this is SO2 and this is HCl is the gaseous product. Next will be preparation of alkyl bromides. Alcohol plus HBr or alcohol plus KBr and concentrated H2SO4. Both reactions are same. HBr is the byproduct of the reaction between KBr and H2SO4. So it is forming RBr plus H2. Here will be these are the products HBr and KHSO4. The HBr will get combined with water, alcohol to form RBr plus H2O. This is the acid salt produced KHSO4 as the byproduct of the reaction, isn't it? Next will be alcohol with Br2 plus red phosphorus. Here an unstable compound PBr3 is formed, which combines with alcohol to form RBr, and H3PO3 will be removed as was in the reaction between alcohol and PCl3. Because this PBr3 is an unstable compound, so it is produced within the reaction. It is produced within the reaction. Isn't it? Next, we will prepare alkyl iodide from alcohol. Alcohol, similarly, I2 and red phosphorus will also combine to form Pi3 as unstable substance, which will get combined with PCl3 to form Ri, and H3PO3 will be removed as the byproduct of the reaction. As the byproduct of the reaction, that H3PO3 will be produced as the byproduct of the reaction. PBr3 is unstable, Pi3 is unstable, so they should be produced, prepared within the reaction by the reaction of your Br2 and red phosphorus and I2 and red phosphorus respectively. Now we are coming to the reaction between alcohol plus Ki and 85% H3PO4. So here the products of reaction between Ki and H3PO4 are Hi plus KH2PO4. Hi will get combined with alcohol to form Ri plus H2O, while KH2PO4 is an acid salt and it will be produced as the byproduct of the reaction. But here is a question. Why do we not use concentrated H2SO4? See, concentrated H2SO4 on reaction with Ki will give KHSO4 plus Hi, that is Ki plus concentrated H2SO4 will form to form Ki KHSO4 plus Hi. Because H2SO4 is an axis and this concentrated H2SO4 acts as strong oxidizing agent for Hi formed and oxidizes Hi into I2. ये Hi को I2 में ऑक्सीडाइज कर देगा. तो Hi plus concentrated H2SO4 is an oxidizing agent, will oxidize into I2. So definitely this oxidizing agent will undergo self-reduction to form SO2 and water will be produced as the byproduct of the reaction. So 2Hi and 2H2O. So here, because H2SO4 has oxidized Hi into I2, which was forming after the reaction of Ki with concentrated H2SO4. So no more Hi will be available to react with alcohol to form Ri. That is why we can't use concentrated H2SO4. This is the reason concentrated H2SO4 cannot be used to prepare alkyl iodide. So here we have first we studied the reaction with Grignard, that Lucas reagent, PCl5, PCl3, SOCl2 to produce chlorides, HBr, Br2 red phosphorus to produce bromides, I2 red phosphorus to produce iodides, KiNH3PO4 to produce iodide. Now we will take some examples of reaction of alcohol with Lucas reagent. Starting from, we have alcohols CH3OH, CH3, CH2OH, CH3, CHOH, and CH3, and third is CH3, COH, CH3, and CH3. So very important note to remember that reactivity of alcohols follow the order. What order? 3 degree, greater than 2 degree, and greater than 1 degree alcohol. So this is 3 degree alcohol, this is 2 degree alcohol, this is 1 degree alcohol, and this one is methyl alcohol. So most reactive is 3 degree and least reactive is this one. We are taking concentrated H2SO4, that is a concentrated HCl with anhydrous ZnCl2. The mixture is called Lucas reagent. We will heat it. Then 1 degree, that is ethyl alcohol, concentrated HCl, again anhydrous ZnCl2. We will heat it. 2 degree isopropyl alcohol we are taking. We will take anhydrous ZnCl2 here. We will heat it. In case of 3 degree, because it is most reactive alcohol, so we will keep room temperature here, and no ZnCl2 will be used to produce CH3Cl plus H2O. Turbidity after long time in case of methyl alcohol. In case of any primary alcohol, we are taking here ethyl alcohol. Turbidity will be produced after 10 minutes. And in case of 2-degree alcohol, turbidity will be produced after turbidity will be produced after 5 minutes. While in case of 3-degree alcohol, the turbidity will be produced immediately. So here turbidity will be produced immediately. Right? Now the question arises that why do we not take anhydrous ZnCl2 in case of 3-degree alcohol? If anhydrous ZnCl2 would be taken with 3-degree alcohols, then dehydrohalogenation reaction will take place and alkene will be the major product of the reaction. Definitely alkyl chloride will be formed, but along with alkene will also get formed, which will be the major product of the reaction. This was all about Lewis reagent. So here one more question is asked. Give a chemical test to distinguish between 1-degree, 2-degree and 3-degree alcohols. So here when 1-degree alcohol is heated with Lewis reagent, it gives turbidity after 10 minutes. 2-degree alcohol gives turbidity after 5 minutes. And 3-degree alcohol, when treated with, not heated, treated with Lewis reagent, it gives turbidity immediately. But keep remember that in case of 3-degree alcohol, anhydrous ZnCl2 will not be used. If it is used, then it will cause dehydrohalogenation and will give rise to alkene as a major product of the reaction. Isn't it? Next topic is there are some name reactions. Number 1, Finkelstein reaction. Number 2, Huns-Diecker reaction. Number 3, Schwarz reaction. There are 3 reactions: Finkelstein, Huns-Diecker and Schwarz reaction. Finkelstein is a halogen exchange reaction where alkyl chloride or alkyl chloride or alkyl bromide are treated with NaI in presence of acetone or methanol as an organic solvent to form alkyl iodide. See, here we have taken acetone or methanol are organic polar covalent compounds. CH3Cl and NaI are also polar covalent compound. So they will dissolve in the they will be dissolved in the solvent to carry out the reaction. These reactants will not be dissolved in water. These reactants will not be dissolved in water. That's why water is not taken as an organic solvent. Second is Hansdeiker. Silver salt of carboxylic acid RCOOAg plus Br2 in presence of CCl4. Br2 is nonpolar, CCl4 is nonpolar. This compound is organic compound and CCl4 is organic solvent. So like dissolves like, non-polar will get dissolved in non-polar, organic will get dissolved in organic in the organic compound. That is why the reaction will be carried out using the organic solvent as a CCl4. So here we will have Br and Br. RBr plus CO2 plus AgBr. Isn't it? Next will be Schwarz reaction. Schwarz reaction में we take, it is also halogen exchange reaction. To form alkyl fluoride. So we are taking here RCl plus AgF or Hg2F2 or COF2 or BiF3 or SbF3 to form RF plus AgCl will be the byproduct. So here in Schwarz reaction, reactivity of alkyl halides is 1 degree greater than 2 degree greater than 3 degree. Just opposite. So 1 degree alkyl halide will react faster and 3 degree alkyl halide will react at a slowest rate. Isn't it? These were the three named reaction to prepare haloalkanes. Now we are coming to the properties. First is physical property. We will come first to the physical state. Lower members are colorless liquids. Liquids why? Because of dipole interaction, not by hydrogen bonding. Always remember, because here is a CX bond, which is polar. So there will be only the dipole-dipole interaction. Second, insoluble in water, because क्यों? They do not form intermolecular hydrogen bond with water. They do not form intermolecular hydrogen bond with water. Compounds which form intermolecular hydrogen bond with water gets dissolved, and those do not form intermolecular hydrogen bond with water will not get dissolved. Reason: for the formation of intermolecular hydrogen bond, there must be one of the three type of bond, either OH bond or NH bond or HF. So neither it has OH bond nor that NH bond nor HF bond. So that is why it will not form intermolecular hydrogen bond with water and will not get dissolved in water. Next will be the boiling point. Number one, boiling point directly proportional to molecular weight. So if we take CH3F, CH3Cl, CH3Br, and CH3I, definitely molecular weight will increase, because halogen, fluorine lowest molecular weight, and iodine highest molecular weight, which is 127 atomic mass, while a fluorine atomic mass is 19. So baki you have CH3, all have 15 unit molecular weight of CH3. And so we will compare the molecular weight of fluoride, chloride, and bromide and iodide. So it is having 127 atomic mass. That's why highest molecular weight of the compound. So boiling point will have the same order: CH3F less than CH3Cl, less than CH3Br, and less than CH3I. Highest boiling point will be of CH3I. Next will be boiling point of alkanes decrease with branching. Why is it? Because branching decreases the molecular size and also decreases the van der Waal force of attraction among the molecule. So we are taking an example: CH3, CH2, 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 Br, 1 bromo, butane, no branching, largest size, strongest molecular attraction. Then we will come to isobutyl bromide. There is a one branch, smaller size. Then secondary butyl bromide, two branches of either side, even a smaller size. And tertiary butyl bromide has a smallest size, the weakest molecular attraction. In this way, the boiling point will follow the order n-butyl bromide, isobutyl bromide, secondary butyl bromide, then tertiary butyl bromide. Isn't it? This is all about the physical properties of haloalkanes. Chemical properties of haloalkanes we will study in the next video. Thank you.